Valence electrons participate in interactions with other atoms. The big thing that you need to know is that valence electrons determine an atom's chemical properties, including its reactivity. We said in class that elements in the same group or family had similar chemical properties, chemical and physical properties. Well, we also said that elements in the same group had the same number of valence electrons, so it makes sense that they would share similar chemical properties. This explains why all the elements in the same group have similar chemical properties and reactivity. Well, let's talk a little bit more about what reactivity actually means. So exactly what does it mean when I say reactivity? Reactivity is a chemical property that determines how elements will react with other elements to form compounds, like NaCl or salt. So basically you have an atom of sodium and an atom of chlorine, and they react together and combine. We're going to talk about this in just a second. So what makes an element reactive? The whole goal of these atoms is to have a full outer energy level, full of electrons. So we find that when outer energy levels are full of electrons, atoms are stable. That means they don't want to react. They are perfectly content to be how they are. They don't want to lose electrons, but they don't want to gain them either. They just want to stay with their full energy level. Then we find if the outer energy levels are not full, that elements will react. They want to gain, lose, or share valence electrons. So looking at this atom model right here, we see that we have 6 valence electrons. We know that the second energy level, right here, which is the outer level, can hold 8 electrons. So I know that we have 2 empty spots. This atom is going to want to react or bond with another atom and gain 2 more electrons to get those empty spots filled. So the closer an atom is to having a full energy level, the more reactive it is. So again, now let's look at a different group. Group 17, the halogens. We said that the closer it is to having a full outer shell, the more reactive it is. So the halogens are very reactive as well, because an atom of a group 17 element or a halogen, such as chlorine, Cl, has 7 valence electrons. It wants to gain an extra electron in order to have a full outer shell. So if I look at this diagram, I see that there are 3 energy levels, and I know on this third energy level that it's going to hold a maximum of 8 electrons. Well, if I look right now, I have 7 valence electrons. So chlorine only needs 1 more to slip in right there to have a full outer energy level. Its whole goal is to have a full outer energy level. So it is going to be very reactive and react with other elements so that it can gain that extra electron. So we just talked about group 1, the alkali metals, and group 17, the halogens. Well, we find that these elements from group 1 and group 17 actually react with each other very well. That's how we get NaCl or salt. What would we do without it, right? So here's a diagram of kind of how that works. So we have a sodium atom and we have a chlorine atom. So we see on our sodium atom that it has this 1 valence electron, and it wants to lose that valence electron so that it will have this full outer shell. So it's going to bond with chlorine and give chlorine that electron. Well, it just so happens that chlorine, we said, had 7 valence electrons, but now by it gaining an electron from sodium, it now has 8, and it has a full outer shell.